So today we're going to talk about lesson 7.5, which is the converse of the Pythagorean theorem. Key ideas. Converse of the Pythagorean theorem. If the equation a squared plus b squared equals c squared is true for the side lengths of a triangle, then the triangle is a right triangle. So here recall that we have two legs, A and B, and a hypotenuse, which is the longest side, always the longest side and always opposite of the right angle. Pythagorean theorem, remember, is a squared plus b squared equals c squared, and it only works for right triangles. Example 1, identifying a right triangle. Tell whether each triangle is a right triangle. In these questions, you're given the lengths of both legs and the hypotenuse, and what they want you to figure out is, are these right triangles? And you can't assume just by looking at them. You can't assume that this is right just because it looks right. You can't assume that this isn't right because it doesn't look right. Because unless the question says that the triangles are drawn to scale, you can't assume that they are. So let's go ahead and start. Letter A. I would first start off by labeling your side. So I think I want this to be A and this to be B, and of course this has to be C. So we know that we're testing out 9 squared plus 40 squared equals 41 squared. So we're going to go ahead and simplify everything. So we get 81 plus 1600 equals 1681. So then we get 1681 equals 1681. These two equal each other, so it checks out, and you would actually answer yes for A because triangle A is a right triangle. Let's test out triangle B. I'm going to go ahead and start by labeling my A, B, and C. And I know C is always the longest side, so just remember that. So we're going to test out 18 squared plus 12 squared equals 24 squared. So go ahead and simplify your equation. So I get 324 plus 144 equals 576. So now we want to see if the left-hand side equals the right-hand side. I get 468. They do not equal each other. So then you would assume that no, triangle B is not a right triangle. Next, we're going to talk about the distance formula. It says here, the distance D between any 2 points, so that's the green line here, x1, y1, so here's the first point, and x2, y2, is given by the formula D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So really, it's using the Pythagorean theorem to find the distance between these 2 points. So here you have the legs, and then the hypotenuse is the green line. So let's see how to use this for our problems. Find the distance between 1, 5 and -4, -2. So first I'm going to go ahead and label my x's and y's. So here I'm just going to call these x1, y1, and this is x2, y2. And it might take you a little bit to remember the formula, so you're going to go back and forth between the screen and your problems. Square root of x sub 2 minus x sub 1 squared plus the y's. So I just rewrote the formula for distance. So next I'm going to go ahead and substitute my values in the formula. So we have our -4 here minus 1 squared plus -2 minus 5 squared. Don't forget to bring the radical down. Okay, then we simplify everything. So parentheses first, right? This is going to be -5 squared plus -7 squared And we keep going. The square root of, so negative 5 squared is 25. Negative 7 squared is 49. Then you go ahead and add up those numbers. So then we have the square root of 1,225. And then we're going to go ahead and root that on our calculator to get 35. So the distance is 35 units.